What I'm going to talk about today is not your standard ePharma talk. In fact, it kind of goes off the beaten path from what we normally talk about. I'm going to talk about technologies and accelerating technologies that extend well beyond social media and mobile marketing. What I'd like to do today is really talk about three things: exponential technologies, or technologies that accelerate over time, the applications of those technologies, and potential implications for the future. So with that, I want to talk about for a minute the idea of exponential trends. You guys remember math, a linear trend versus an exponential trend? Well, if you look at the first half of this graph, the blue line is a linear trend, and the green line is a curve that's an exponential trend. In the first half of this graph, it's very hard to tell the difference between them. They're very close together. Now, if you want to project out the second half of the graph, where the line is going to land, it's pretty easy. You just follow the line straight forward. The curve, on the other hand, trying to figure out where that will land is a little harder. So typically, when we think about this, we expect the line to land there and the curve to maybe land there. And certainly, there's a significant difference between those two trends. On the other hand, if it's an exponential trend, the middle of the graph is what they call the knee of the curve. It's the inflection point, where after which that trend goes vertical. It looks like this. So an exponential trend often surprises people at the back end because the rate of change and the amount of change is so much greater than we expect in a linear trend. So if you look at the delta between the blue line and the green line, it's huge. So another way to think of this is there's a math problem called the lily pad problem. And it says if you had a small lily pad and it doubled every day, such that after 30 days it covered an entire pond. The question is, on what day does it cover 25% of the pond? The answer is day 28. Because on day 29 it doubles to 50%, and on day 30 it doubles to 100%. And it's not really intuitive, right, that it would be at 25% on day 28. Another way to look at it is multiplying out the numbers. If it doubled every day after 5 days, it would be 32. 10 days over 1,000. 15 days over 32,000. Now, a little exercise for everybody in the audience. Pick a number. Where do you think it's going to be after 30 days? The answer is over 1 billion. Over 1 billion. So, again, it's a little bit surprising how quickly things accelerate after this inflection point in the knee of the curve. So, what I'll talk about today is this phenomenon of accelerating or exponential technologies as applied to a number of technologies. 5 of them: information technology or computing, which we're most familiar with, robots and artificial intelligence, 3D printing, nanotech, and genomics. So with that, let me start with infotech. In the 60s, Gordon Moore from Intel predicted that chip capacity would double every year to 18 months for the foreseeable future. So that's, we're all familiar, that's known as Moore's Law now, and it's proven to be true over the last 30, 40 years, such that a computer that fit in a building 20 years ago now fits in our pocket. And based on current trends, in 20 years will fit in a red blood cell. So we've seen a billion-fold increase in price performance of computing over that period of time, which is mind-blowing. If you move on to robotics and artificial intelligence, this is basically, robotics is the extension of human capabilities, but unlike a crane, a caterpillar, a backhoe, or something like that, this is the extension of our physical capabilities with some intelligence built in. So if you think about robots, maybe you're thinking of, this is the stuff of science fiction, right? One day Will Robinson won, the Terminator. But this is the classic thing that science fiction movies like to focus in on. And we probably think of robotics as the Honda plant, where they're welding the cars, or perhaps the Roomba. Anybody have a Roomba here? Come on, this is a tech crowd. No Roombas. There's one. All right. So, I don't think they work that great, actually. But, it sweeps your floor. It's the robot. But actually, it advances significantly more than you might think. And let me show you a brief clip. This is Big Dog from Boston Dynamics. It's climbing a hill on its own. Got a 100-pound pack on its back. And this is on ice, and it's able to right itself. Here's a little instant replay of robot cruelty. It's not going to look at how it's able to right itself. Here, next is fine motor control with the robot. dribbling a basketball or a tennis ball, baseball, catching a cell phone. And this is a random Rubik's Cube that's being solved by a robot using computer vision. Now, for the record, I can solve one of these in 7 or 8 hours after I move the stickers around. So this is amazing. So the next thing, you can also, those are autonomous robots. But robots don't necessarily have to be autonomous. They can also be used to extend human capabilities directly. So what you're seeing on the left is a surgeon who's manipulating controls and looking into essentially virtual reality monitor. And on the right is the Da Vinci surgical system, where essentially he's doing surgery remotely by manipulating the system. And it's very accurate, very accurate. So, a question. Does the surgeon in the future necessarily have to be in the same room as the patient? Yep. Or might it be possible for someone to find the best cardiovascular surgeon in Austria and be operated on in Cleveland? Maybe. So, next let's talk about 3D printing. Anybody heard of 3D printing here? That's a pretty hip crowd, so it doesn't surprise me. So, what is 3D printing? It's the ability to print 3 dimensions. I guess I gotta get deeper than that. But 3D printing is essentially, instead of printing on paper, text, and images, is the ability to print physical objects. So it reminds me of the Star Trek replicator, this thing, this little device that can build objects out of thin air, Stardate circa 2170. Oh, by the way, any of you Trekkies in the audience? I made this date up, so don't come to me a break. It was actually Stardate 22. It's cut us some slack. But if you look at this Star Trek replicator, which again, if you look at, I didn't use this term when I showed the exponential curve, but we all have sort of a universal human trait that we have what's called a linear bias. And a linear bias says I underestimate the change in the future. So, there's a lot of stuff in science fiction, from Minority Report, from Star Trek, that we thought, universal translators, all these things that we thought of way out, in the 2100s. And in fact, they're available today. So if you look at this is a 3D printer. They printed out a wheel rim. All right? So essentially, they just, they layer on different substances, first with plastics and different polymers, and now with metal, titanium, all these different materials. So this is a 3D scanner. It can scan any object and create a 3D rendering. For those of you with children, it kind of reminds you of the Honey, I Shrunk the Kids machine a little bit. And so you can either scan an object and create a 3D rendering, which you then print out, or design something from scratch on a computer in AutoCAD or whatever, and then output it to physical reality. There's a company called Shapeways. I think it's shapeways.com, I believe. And they're in the business of essentially printing out objects. They have high-end 3D printers. You can go to their site and pick out objects you like, and either print them as is, or you can manipulate them and have them print them, or you can perhaps scan your own object like this. Let's say you had a Tyrannosaurus Rex, a small one, a toy, and you wanted to scan it and send it to them, ask them to enlarge it and print it so you can terrify your children. So that's an opportunity. And then you can also create a disturbing punch bowl for a party if you like. So this is a troubling image. I have a couple of others that are troubling later. So the next technology is nanotech. So nanotech, what is it? It's basically a construction project. We all do construction, building things all the time, but typically we build things using metal and wood and nails and super glue. And what nanotech is building things at the atomic level by arranging atoms very precisely. So we've been doing nanotech for a long time in the context of working in a small scale for chip design and all these other things. But the trick now is to start to create objects and little machines at the atomic scale that can perform different kinds of actions when you build them. And I'm going to talk about a couple of medical examples later. But just to give you a sense of scale, in a single grain of sand, there are 78,000 trillion atoms. At least according to Wikipedia, so I can't necessarily say that's true, but I think that's true. So that's nanotech, and the future of nanotech is really getting us to scale and low cost. So the next frontier on nanotech is being able to create large volumes of materials cheaply, which would enable things like high efficiency, low cost sheets of solar panel. It would enable diamond strength materials that are ultralight, 50 times the strength of steel, such that you could have an unbreakable bicycle that's 5 ounces, 120-pound Lexus, you know, those kinds of things. So interesting stuff with nanotech. The next one is probably closest to our world, which is genomics. And genomics is basically working with DNA, and DNA is the software of our minds and bodies. It designs and essentially controls the design of everything about our biology and that of other species. So like other exponential technologies, and I should say, by the way, I've heard it said that the genomics is the new IT. And the reason they say that is that DNA is actually digital data storage. It's digital. But instead of storing digital data on a silicon chip with ones and zeros, it's storing it biologically in the form of 4 nucleotides that they designate by the letters A, G, C, A. So it's essentially very dense digital storage. And what we do is sequence the DNA in order to decode those strings of, software code, essentially. And like other exponential technologies, it is radically, exponentially dropping in price and increasing in volume. So this is a sort of an exponential trend that shows the decreasing cost of DNA sequencing. 1990, $10 per base pair to sequence, and there are about 3 billion base pairs in DNA. And we're now